So let's take a look. Section 2.2, we're actually going to probably take, section 2.2 is kind of long. It's got a lot of stuff in it. So we'll probably take 3 or 4 different days. This is what, our second or third day? I think our third day on this stuff. All right, so this is what it's called. Test an equation for symmetry. Well, I know what an equation is, and I had to test stuff, but what in the world is symmetry? All right, well, I'm glad you asked, because I'll show you. So take some good notes here. I'm going to draw a little x and y axis, but actually, let's put this a little more in the middle. Come on. There you go. Like this. All right. There you go. What I'm going to do, I was looking at this morning, and I actually practiced drawing these things because I got some weird looking graphs. I wanted to know if I could actually draw them on this program. I'm going to do it a little different than what I had set up, but let's draw this. I'm going to draw a graph right here. Let's put it in red. It's not really like a particular equation of a graph. It's just some crazy looking thing. So just kind of make it look like that. There you go. That's pretty good, isn't it? Good thing I practiced. All right. So that's our original equation. And I'm actually going to put a dot right there. You'll understand why I put that dot there in a second. So really, what quadrant am I in right here? Huh? 1. I'm in 1. Okay, it goes 1, 2, 3, 4. Okay, this is the first quadrant. Top right, and it goes what? Clockwise or counterclockwise? Counterclockwise, okay? 2, 3, 4. So I'm in the first quadrant. So what would the, I don't know exactly like how far over I went, but what would be my coordinates, my general coordinates? I go over which direction? I go over x, and I go up y. Very good. Okay? And that's positive, right? In the first quadrant, it's positive. Would you agree? Yes. Okay. So that's my xy right there. Now, what I'm going to do, let's talk about symmetry. Symmetry kind of means it's the same, but it's like in a different spot. It's in a different place. That's kind of what symmetry is, all right? If it's symmetric, it looks the same. It's got the same shape. It's got the same size and all that, but it's just located in a different spot. It's not like an official definition, but it's good enough for us to understand. So what I'm going to do is this. This is what I practiced today. Hopefully I can do it. I had to look to see. I got to do. What I'm going to do is I copied that graph, and now I'm going to paste it right on top. So if you look at it, watch this. Well, maybe. Come on. There we go. Boom. Oh, that's what I mean. See, there you go. See, there's the graph right on top of it. Do you see that? Well, it's not on top of it now, but let's put it on top right there. So what I'm going to do is I'm going to take this. I'm going to hit transform. I'm going to hit these dots. It took me a long time to figure out how to do this. And I'm going to write flip vertically, I think. Watch. Boom. Nope, I want to flip vertical. So what I'm going to do is this. There we go. See, it's the same exact graph. Would you agree? Because I copied it. Hit Control-C. You know how to copy, right? On programs like this. And what I did is I just flipped it, basically. Isn't it the same size and the same shape? Yeah. All I did was flip it over which axis? The x-axis. That's right. So let's write down our axes. So that's the x-axis, and of course that's the y-axis. And just to make this a little different, let's change colors. I don't know. Let's make it this green. How's that? You with me so far? Okay. Now I'm going to put a dot kind of where this was. See how this went up and then it started going down? I put the dot right there. You can put the dot anywhere. Okay. I just picked a spot that looked like I could mimic it over here. So where would this dot be on this green one? Would it be here? No. Would it be here? No, it would be where? Down there. So put a dot right there. So what I want you to see is this. I want to see what is our ordered pair. If I call this point xy, what am I going to call this point right here? Boom.
I know it.
Okay, Cam, go ahead and tell me.
It's going to be positive x and negative y.
Very good. You got it. All right, so we got x and negative y. So I go over to the right and I go down. Would you agree? What quadrant am I in with the green one? Fourth quadrant, okay? So anytime you have a number in the fourth quadrant, how do you get to there? You always go to the right and you go down. It's positive, then negative, okay? We say that these two lines right here, the red one and the green one, are symmetric with respect to the x-axis. Hear what I just said? Write it down. I'm not going to write it down. You write it down because I'm going to have too much stuff here to write too much junk. So the green one, this one right here, this fourth quadrant, it's symmetric. Well, I'll write the word symmetric. It's symmetric. Let's just say this. They say with respect. Let's just do what they say. You could say it a couple different ways. With respect to the, which axis? Which one did we flip it? The x-axis. I want you to see something though. Look at the x and y. Look at the signs for the x and y. The first one, our original one, was just positive x, positive y. Our second one, what did we change? We flipped it over the x-axis, right? We kept it the same. All we did was flip it over the x-axis. But what sign did we change? Did we change the sign of the x or did we change the sign of the y? It's pretty easy. What is it? The y. That's right. So if I want to find an equation that is symmetric with respect to the x-axis, what sign am I going to change? I'm going to change the y. You with me on that? Okay, it's the opposite one, all right? It's symmetric to the x-axis, but what sign do I change? I change the sign of the y. That's how we find all the points. I mean, you could list a whole bunch of points over here. This would be like x1, y1, but this would be what? x1 negative y, or yeah, x1 negative y1. Okay, you with me on that? So I could put a whole bunch of points, and in the book, I think the first kind of example, right before the example, they put a whole bunch of points on there just to show that they match up. I decided just to make it easy, just put 1 point. So this one and this one match up, right? You go over and up or down the same amount. You just go different direction. That's all. Everybody got it? Okay. Now what we're going to do is flip it over which axis now? We did the x-axis, so we're going to flip it over the y-axis. So let me try this again. See if I can do this. Copy, paste it in place. Okay. And now, there we go. And now what I'm going to do is flip it. So I come over here, I click this, and I flip horizontally. I got to move it over, though, because it just flipped it where it is. See that? Let's move it so it connects right there. And let's change the color of that one. Let's make this blue. Okay? Now what did I do to it? I flipped it over the what? The y-axis. So we're going to say that the blue one is symmetric to the red one with respect to what? The y-axis. Okay? And let's do that in blue. Let's write that down. So it's, I'll write up here. So it's symmetric. We're going to be doing this 3 times now. Oh, got to spell right. Symmetric. We could just say to the y-axis. Is that all right? We'll just say it like that. That should be good enough. So it's symmetric to the y-axis, but a lot of times professors say symmetric with respect to or about. Some people say it's symmetric about the y-axis. All right, there's a lot of ways you could describe it. We'll just say it like this. It makes it a little bit easier. It's symmetric to the y-axis. So it's the exact same graph. What did we do? We just flipped it over the y-axis. It's kind of like a mirror image, isn't it? If I stuck a mirror like right along the x-axis and I flipped it like this, or a glass or something, right, you could see through it, what would it look like? It would look like this red one is going down here like this. What if I put a mirror along the y-axis? It looks like that red one would flip over here like this. You with me on that? So let's put our dot. Where was our dot? About right there. Come on, pen, help me out here. There we go. That's close enough. All right. And let's put the ordered pair. So what would our ordered pair be in the, what quadrant is this, by the way, the blue one? Second quadrant, right? So what would our ordered pair of this point be? If this was xy, this was x negative y, what's our ordered pair there? That's right. It's negative x and positive y. Now remember, when we flipped it about the y-axis, what did we change? We didn't change the y, the sign of the y. What did we change? The sign of the other one, which is the x. Does that make sense? All right. We're getting somewhere with this, okay? Eventually what we're going to do is they're going to give you some equations with x's and y's and numbers and stuff, and we got to figure out another equation that's symmetric to that one. Symmetric to the x-axis, symmetric to the y-axis, and the next one we're going to do is called symmetric to the origin, which means you flip it over the x and you take it and you flip it, guess what? Over the y, all right? And that's what we're going to try to do now. Let's see if I remember how to do that. So I'm going to copy and paste, copy, I'm going to paste in place, all right? And then I'm going to come up here to transform. I'm going to flip it. Actually, I could have done one of these. That's right. I'll show you how to do it twice. So we're going to flip it vertical, and we're going to flip it what? Horizontal, all right? And now I'm just going to move it over so they all match up. Boom, 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 boom. Right there. Let's move it up a tad. Does that look pretty good? Let's change the color of that one. Looks purple, but it's really not. I'll make it this yellowish looking color. There we go. Oh, look how pretty that is. All right, so let's put a little point. Let's make it, boom, right there. Okay. And, oops. Come on. There we go. Let's figure out what our point is here. Now, we flipped it over the x-axis and we flipped it over the what? The y-axis. Good. Play along. All right. So what are we going to change? If you flip it over the x-axis, we change the sign of the y, right? If you flip it over the y-axis, we change the sign of the x. So what's our ordered pair going to be down here? Negative x, negative y. You with me on that? It's important. What we just did right there, it's important for what we're going to do later. Okay, this in and of itself is okay. But, let's call this symmetric. I said it once. Do you remember what I said? It's symmetric, not to the x-axis, not to the y-axis, but it's to the origin. Very good, you remembered. So it's symmetric. Oops, yeah, it looks like an N, I guess. Symmetric to the origin. Is everything on the screen there? Yep. Look at that. Pretty good, huh? That's way better than what I did in my notes, because I did a whole bunch of stuff, different graphs and stuff like that. And I think we are ready to write down this next part. And we're close to done. All right. Everybody understand what we're doing here? We're just flipping stuff, right? We take an equation. It could look like anything. It doesn't have to look like that exact graph. Okay, it could be any looking graph. But if we flip it over the x-axis, that's symmetric to the x-axis, okay? But we change the sign of the y. If you flip it over the y-axis, right, that's symmetric to the y-axis, but we change the sign of the what? X. If you flip it over the x and the y, you change the sign of both of them. That's symmetric to the origin. Very good. Yeah? All right, good. So now, let's write this down. With that said, this should make a little bit of sense, because they're going to ask you to test an equation for symmetry. They're going to say, test this equation to see if it's symmetric with respect to the x-axis, test it to see if it's symmetric with respect to the y-axis, and what's the next thing? Test it with respect if it's symmetric to the what? Origin, okay? So that's what we're going to do. So here are some tests for symmetry. I don't think I'm going to write down quite as much as I did in my notes. It's in the book. I think it might even be like in a box or something. Yeah, it's in a blue box on page, what's that, 168? Is that what it is? Right here, blue box. Yeah, 168. So it's in there if you want to look at it. It's got all the little details and stuff, but we're just going to do this. So if they, not me, but if they ask to test to see if it's symmetric with respect to the x-axis, what are we going to do? We're going to replace, it's going to be an equation, all right? It's going to have an x and a y, going to have an equal sign, Going to have some numbers. What are we going to do? We're going to replace, are we going to replace the x with a different number? No. What did we do when we flipped it over the x-axis? We replaced this y with what? A negative y. Do you see that? And that's what I'm just going to do. I'm just going to write this down so it's all in one place. Let's drop that down. So we're going to replace the what? Not the x, the y with what? A negative y. Okay? And then we're going to simplify it. Simplify it. Okay? I'm not going to write this part down, but this is what you do after you simplify it. What you're going to do, you're going to replace the y with a negative y. Then what you're going to do is compare it to the original equation. All right? If it's exactly the same as the original equation, when you replace the y with a negative y, then it's symmetric with respect to the x-axis. Hear what I just said? A lot of you guys have your heads down, not writing. You should be writing and looking up here. So that's how you find if it's symmetric to the x-axis. So the rest should be pretty easy now. What are we going to do? What are we going to replace if we want to test if it's symmetric to the y-axis? We're going to replace the what? The x with, that w and slash means with, a what? A negative x. And what are we going to do? We're going to simplify it. Okay? And then what we're going to do, I'm not going to write this down, it's in the book, but then what we're going to do, after you simplify it, you compare it to the original. If it's exactly the same as the original, then it's symmetric to the y-axis. You got it? If it's not exactly the same as the original, then it's not symmetric. You'll see what I'm talking about once we actually do one of these examples. What's the other thing we need to see? We need to test if it's symmetric to the origin. So we're going to test to see if it's symmetric to the origin. So guess what we're going to replace with this one? The x and the y. Very good. So replace a y with a negative y and, right, an x with a negative x. And I don't need to write the rest down. You're going to simplify it. You're going to compare it to the original. If it's exactly the same as the original, then it's symmetric about the origin. What do you think? You're like, I have no idea what you're talking about. I get it. Let's do an example and let's see. Oops. That's in the book. It's on 168 in a blue box if you want to look at it. It gives you all the little details. I did skip a few examples. I kind of combined them all in that pretty little rainbow color graph thing we just did. All right, so this one, come on. Oh, there we go again. Example 9. All right, and here's what you're going to be doing. You're going to test this equation for symmetry. Okay? You're going to test that for symmetry. So you're going to do 3 tests. Actually, does that example say to test just for the x and y axis? Somebody have that? Example 9. Somebody look at example 9 in their book. Who's got example 9 in front of them? Look at example 9. You should see a 4x squared over x squared plus 1. Do you see it? Anybody with me? Yes. Okay, does it say, what does it say? Because I don't have the book in front of me. So it says, does it say test for the x-axis and the y-axis, or what is it? Right, over x squared plus 1 for symmetry. And that's it? They don't say anything else? Okay. For some reason, I did not do the origin, so I don't know why. Anyway, let's do this. Well, actually, if you do the x-axis and the y-axis, if one of them is not symmetric, then it's not symmetric about the origin anyway. Okay, so that's probably why we only did 2 of them. So let's test for the x-axis. That's what we're doing. Okay, testing this to see if it's symmetric about the x-axis or with respect to the x-axis. So what do? We replace what? We replace the y with a negative y. So instead of y equals this, we're going to put negative y equals all this stuff. Now this next part, the simplify part, sometimes can be a little tricky. So we replace the y with a negative y. Now, what I want to do when I say I want to simplify it, I want to get y by itself and see if it's exactly this. You're probably thinking, well, why would it be that? Because if you made that a negative, it's not going to be the same. Well, sometimes it is, all right? So watch. How do I get rid of this negative in front of here? What in the world's going on out there? Somebody's dying. That's kind of normal, huh? So anyway, all right. So we want to get rid of this negative y. It's like a negative 1, right? So how do you get rid of that negative 1? What if it was negative y equals 3? What would you do? You could multiply or divide, right, by a negative 1. It really doesn't make any difference, okay? And so what would y equal here? It'd be negative 3, okay? But that's not what it is. It's a little bit different. So how do I get rid of this negative y, though? Let's just not divide. Let's multiply everything by a negative 1. So really, what does that do? Gets rid of this, right? Because negative 1 times negative 1 is positive 1, y. And you're not going to multiply like every single number in here. All you have to do is multiply that whole thing by a negative, which means I could just stick it right there. Okay, now look at this. Is this thing right here? Remember, it says, remember what we have to do? Compare it to the original and see if it's exactly the same as the original. Is this exactly the same as this? It's not, is it? All right, because 4x squared is not the same as negative 4x squared. So is it symmetric with respect to the x-axis? No, it's not. That's part of your answer. Okay? Sometimes it will be. Sometimes whatever they ask it, whatever you replace this with will equal this. In this particular case, does not. So let's try another test for the what? For the y-axis. Now, if it's not symmetric with respect to the x-axis, it's not going to be symmetric to the origin, okay, because the x doesn't work. The x and the y has to work, all right? So let's do this. What do we, if we want to see if it's symmetric to the x or the y-axis, what do? We replace what? We replace the x with a negative x. So remember what our thing was? It was 4. Now, instead of x squared, what are we going to make it? Negative x squared. See that? Right? I'm replacing the x with a negative x. And then I'm going to simplify it and see if it looks like the original. So I took that x and I stuck a negative x in there. I didn't replace the y with anything. I already did that up here. What else do we need to? We got another x down here, don't we? So instead of x squared, what are we going to make it? Negative x, make sure you put it in parentheses. It's a big difference. Plus 1. See what we did? So I took the x's and I replaced it with a negative x. Now, let's simplify. Well, what's negative x squared? It's still just x squared, isn't it? Right? Because when you square a negative, negative times negative is what? A positive. So it's still 4x squared. Kind of looks like that, doesn't it? Does it do the same thing down here? Absolutely. What's negative x? That quantity squared. Negative x times negative x is positive x squared. So that's a positive x squared plus 1. Does this look like the original? Yeah. It does. So guess what? This equation is what? It's symmetric to the y-axis. So we're going to put a yes right here. I'll even put an exclamation point because I'm so happy about it. Okay? So, yes, it is symmetric to the y-axis. We good? Now, if both of these things were true, if this happened to be symmetric about the x-axis and symmetric about the y-axis, then it would be symmetric to the origin. But since it's not symmetric to the x-axis, it is not going to be symmetric to the origin. So I don't even have to do the test for that. You with me on that? Okay. It's a little weird. I get it. You know, it's definitely not Algebra 1. Remember how I always say, you guys did this in Algebra 1 or you did this in Algebra 2. You didn't do this, okay, in Algebra 1 or Algebra 2. So let's take a look at our homework. It's on the paper I gave you, but I like to write it down anyway, just in case. So it's section 2.2, part 2. And it's pages 171, 172. And you're doing a 29 to 53, but you're just doing the odds. You got the answers in the back. Now look, don't just flip the answers to the back and write down the answer. That's ridiculous, okay? Try it, okay? Try it. Now, some of the questions on here are going to be slightly different than what we did in class, but with the stuff that I taught you, I think you should be able to look at it and understand what they mean, okay? So let's do some real effort on this, okay? Do some real effort on it, and we'll go over this tomorrow in class. Let me stop.